Least common multiple. So think about those words. The smallest multiple that the numbers have in common. All right, so before we get there, let's just write down what a multiple is. So a multiple of a number is the product of that number, and any non-zero, so it can't be zero, whole number. Okay, a multiple of a number is the product of that number and any non-zero whole number. So for example, if we were going to list the multiples of 5, the first multiple you would get by doing 5 times 1, right? That's the first non-zero whole number. So 5 times 1 is 5. 5 times 2, 10. 5 times 3, 15. 20, 25, 30. You get the idea. Okay, so those are the multiples. Now, the least common multiple, LCM, is, it's just what it says. It's the least multiple, or the smallest multiple, that both numbers have. So if I asked you for the LCM of 5 and 6, it's kind of like in your head you're thinking, all right, I'm going to go up by 5s. Here's multiples of 5. Here's 6. 6, 12, 18, 24, 30. Oh, there it is. There's the smallest one that they have in common. Now again, this is a fine method. I think you can understand it that way. Totally fine. Again, when we get bigger numbers, things with variables, it's going to be kind of a pain to list all the way out until you find what you need. So we're actually going to use a similar method to the greatest common factor, which is nice because then you can kind of find both at the same time. So here's our method. And I guess I'll just write it out because it's very similar to the GCF. So step 1 is exactly the same as GCF. So we're going to find the prime factorization of the numbers, list them out. You're still going to circle the common factors. The only change is in step 3. So for the GCF, you multiplied just the circled factors together. For the LCM, you're going to multiply the circled factors and the non-circled factors. So multiply circled factors and non-circled factors. Okay, so let's see what that looks like. Let's try the LCM of 6x to the third and 18x to the second. All right, 6x to the third, 18x to the second. Okay, let's break down 6. That's 2 times 3, and it has 3 x's. 18 is 2, 3, 3, and 2 x's. We're still going to circle common factors. Okay, but the LCM is going to have more in it, so it's got a 2, a 3, the circled x, and the circled x. So that's all the circled things, right? And they still count as one factor once they're circled. Then everything without a circle also counts as a factor. So there's another x, and there's another 3. So that's 2, 6, 18, x to the third. That's the least common multiple. I should put that there. Okay? All right, let's try a few. Go here. So we'll say we're going to try, let's try the LCM of 12x and 15xy. So 12x, 15xy, LCM. All right, pause. All right, 12 is 2, 2, 3, and it has an x. 15 is 3 times 5, x, y. We've got a 3, we've got an x. I always do the circled factors first. You can pick your own strategy, whatever you want. So I'm going to say it's 3x and then everything else. 2, 2, 5, y. So that's going to be 6 times 10, that's 60, x, y. All right, good. Okay, try another one here. LCM of 8m squared and 14m to the 4th. Okay, 8m squared, 14m to the 4th. Go ahead and try it. Pause. 2, 2, 2, m, 2, 7, m, 2, m. So you got 2, m, then you got 2, 2, 7, m. Okay, so that looks like it is. That's 8 times 7, that's 56, m to the 4th. One more, why not? LCM of 250y squared and 150x. 250y squared and 150x. All right, pause. All right, 250, 2, 5, 5, 5, y, y. 150, 2, 5, 5, and a 3. And we've got an x. So boom, boom, boom. That's it. So 2, 5, 5, the 5, the 3, the y, the x. Oh boy, I'm thinking that's 750 xy squared. All right. Okay, now there's one other catch. Sorry, forgot about it. If we're going to do, and you saw this on your GCF homework, if we're going to do 3 terms, for GCF it would have to, all 3 would have to have a circle. For LCM, we're going to use a different method. So I'll kind of show you both since we didn't talk about it. So if there are 3 numbers, let's just write it here. So the GCF needs, how do I say this? All 3 to have a common factor in order to circle, basically, I guess, in order to circle the factor. I'll show you what I mean. For the LCM, we're going to use the happy method. I'll show you what that is. Okay, so we'll do it with an example here. So let's try to find the GCF and LCM of 50, 75, and 120. Okay, so we're going to start it off the same. We're going to line them up. 50 is 255. 75 is 355. And 120 is 2, 2, 2, 3, 5. All right, let's do the GCF first. For the GCF, all three have to have the factor. So this doesn't have a 2, I can't circle a 2. Ooh, it looks like they all have a 5. So the GCF is 5. We're done. If we could circle another one that they all had, we would multiply them together, just like normal. Okay, the LCM, here's the happy method. You have to make sure each number's happy. The way they're happy is that they have all of their factors represented in the LCM. So, start at the top. 50 needs a 2, a 5, and a 5. So we're going to put it in the LCM, and then 50 is happy. Okay. A 75 to be happy needs a 3 and 2 5s in the LCM. There's already 2 5s in there, so we need to put the 3 in there, and now the 75 is happy. 120 needs 3 2s. There's 1 in there, so we need 2 more. It needs a 3, got it. It needs a 5, got it. So 120 is happy. And that will give you your LCM. What is that? 10, 150, 300, 600. Okay, so their GCF is 5. Least common multiple, 600. All right? Okay, good job, guys.